With the discovery of the neutron in 1932, the list of fundamental particles was thought to be complete. There are three fundamental particles: the proton, which has a charge of +1, the neutron, which has no charge, and the electron, which has a charge of -1. The masses of the proton and the neutron are almost, but not quite, the same. These particles are in the nucleus of the atom, down in the center of the atom covered by the electrons. The mass of the electron is very small compared to the masses of the proton and neutron. Most of the space of the atom is taken up by the electrons. Since the electrons take up most of the space of the atom, and the protons and neutrons are buried deep in the atom, ions are made by either adding electrons to make a negative ion, or removing electrons to make a positive ion. It is electrons that interact when atoms combine to make compounds. So electrons are responsible for the chemical properties of the elements. But it is the number of protons that determines the number of electrons in a neutral atom. So it is ultimately the number of protons that determines what element we are talking about. All atoms with the same number of protons will have the same chemical properties, regardless of how many neutrons are in the nucleus. When atoms of the same element, that is, atoms with the same number of protons, have different numbers of neutrons, we call them isotopes. Because we are mostly interested in the chemical properties of the atoms, we usually do not pay much attention to the number of neutrons. However, when we are interested in the number of neutrons, we need some way of showing this in our atomic symbols. Around the symbol of an element, in this case copper, there are four regions we use to show important information. First, below and to the right of the symbol, we place a number which shows the number of atoms of the element in a molecule. If no number is written, we assume the number is 1. Next, above and to the right of the symbol, we place a number that shows the charge of the species. If no number is written, the species is assumed to be neutral and have a charge of 0. These two regions are used whether we care about isotopes or not. However, the areas to the left of the symbol, above and below, are used almost exclusively when we are interested in the isotopes. The number below and to the left of the symbol is the atomic number of the element. The atomic number is the number of protons in the nucleus. It is not always shown because there is only one atomic number for each element. And if we know the symbol, we can always use the periodic table to find the atomic number. The number above and to the left is a critical one when dealing with isotopes. It is the mass number, which is the number of protons plus the number of neutrons. With these two numbers and the charge of the species, we can determine the number of protons, neutrons, and electrons in the atom. Here is a symbol for an isotope of copper 65 with a charge of 2+. How do we find the number of protons, neutrons, and electrons that are present? First, the atomic number of the element is the number of protons. The atomic number is in the lower left side of the symbol, 29. So, the number of protons is 29. The mass number, 65, is in the upper left and is the number of protons plus the number of neutrons. Rearranging the equation, the number of neutrons is the mass number minus the number of protons. This is 65 minus 29, or 36 neutrons. The charge, 2 plus, is in the upper right of the symbol, and is the number of protons minus the number of electrons. To find the number of electrons, we take the number of protons minus the charge. In this case, that is 29 minus plus 2, which gives 27 electrons. Let's go through the same process for arsenic 77, 3 minus. The number of protons is the atomic number, which in this case is given as 33. The mass number is 77, so the number of neutrons is 77 minus 33, or 44 neutrons. The charge of the ion is 3 minus, so the number of electrons is 33 minus a negative 3, which is equal to 33 plus 3, or 36 electrons. For tellurium-125, 2 minus, no atomic number is given here. However, we can find the atomic number from the periodic table. The atomic number of an element is shown in the box for the element. In this case, tellurium, symbol Te. The atomic number is the whole number in the box. In this case, 52. Now back to tellurium. The atomic number is 52, which means we have 52 protons. The number of neutrons is 125 minus 52, or 73 neutrons. And the number of electrons is 52 minus negative 2, or 54 electrons.